Good morning, my dear students. Now we discuss Unit 5 Power Quality Enhancement using Custom Power Devices, which is called CPD, Custom Power Devices. So, while coming to the Unit 5, is a power quality enhancement using custom power devices. The Unit 5 contains Introduction to Custom Power Devices, Network Reconfigurating Type, Solid State Current Limiter, Solid State Breaker, Solid State Transfer Switch, Compensating Type Dynamic Voltage Restorer, Unified Power Quality Conditioner, only principle of operation. So, introduction. What is need to go custom power devices? So, in power quality, maintain power quality, we face a number of problems. So, by using different techniques, we maintain the power quality. Further improvement of power quality, we can use new techniques, that is a custom power devices. By using custom power devices, we enhance the power quality. So the concept of custom power was introduced by N.G. Hingorani. Like flexible AC transmission system, FACS for transmission system, the term custom power pertains to the use of power electronic controller for distribution system. Custom power enhances the quality and reliability of power that is delivered to customers. Under this scheme, a customer receives a prescribed quality power. So prescribed or pre-specified. So the quality of power is increases abnormally. So these are the very costly equipments, but the quality of power is very more compared to normal devices. Pre-specified quality may contain a combination of specification of the following. So frequency of rare power interruptions. So the frequency changes also we compensate by using custom power devices. Magnitude and duration of over and under voltage within specified limits. Low harmonic distortion in the supply voltage. Low phases unbalance. We balance the system by using custom power devices. Low flicker in the supply voltage. Frequency of the supply voltage within specified limits. Custom power park. It can serve customer who demand high quality power and are ready to pay a premium price for service provided to them. So they must provide, the customer who need custom power devices, they must pay premium prices compared to normal devices. Whenever we using the customer power devices, the customer has to pay premium price for service provided to them. So what are the basic problems and what are the effects? We see the basic problem is voltage sag, because voltage sag, the effect is variable speed drive and computer trip out. In transients, tripping, components failure, flash over of instrument installation, hardware rebooting, software glitches etc. Harmonics are excessive losses and heating in motors, capacitors and transformers connected to the system. Flicker causes effects are visual irritation, light flicker. Voltage swell causes overstress insulation. Under voltage cause excessive motor current. Over voltage cause overstress insulation. Unbalance cause motor heating. Interruption cause complete shutdown in the system. While power electronic controllers on transmission level are used to control the power flow and to increase the stability, devices on the distribution level, often called custom power devices. The CPD is distribution level, are mostly used for improving the power quality. Custom power pertains to the use of power electronics controllers in a distribution system. CPD are capable of mitigating multiple power quality problems associated with utility, distribution, and end user appliances. CPD is considered to be the most efficient method that electric utilities will offer to their customers. So normally CPD can be classified into two types: network reconfigurating type, second one is compensating type. In network reconfigurating type, there is a static transfer switches, static current limiter, static circuit breakers. These are the network reconfigurating type. In compensating type, this is the DStatCom, DVR and UPQC. The power electronic controllers that are used in the custom power solution can be network reconfigurating type, already I told that, and compensating type. In network reconfigurating type, there is a solid state current limiter which is called sscl, solid state breaker SSB, solid state transfer switch. These are the advanced equipments compared to normal one. Suppose the current limiters also are number of current limiters here, but solid state current limiter operation is different. The compensating devices either compensate a load, either correct its power factor, unbalance, etc., or improve the quality of the supplied voltage. The compensating devices are distribution StatCom, that is nothing but DStatCom, dynamic voltage restorer, unified power quality conditioner, that is called UPQC. The solid state current limiter or SSCL is a power electronic based system designed to limit the fault current in transmission and distribution application. The SSCL can limit both transmission and distribution currents. The SSCL monitors the current in the main bus of the system and dynamically inserts additional impedances into the line in the event of a fault. So this is a solid state current limiter. Please observe the diagram. This is a sending end, this is a load end, in between there is a feeder. So in between we put a solid state current limiter that contains inductance Lm with two switches, two opposite switches, and also a snubber circuit which consists of capacitor and resistor. An SSCL consists of a pair of opposite poled switches in parallel with the current limiting inductor Lm. In addition, a series RC combination with a resistance of Rs and a capacitance of Cs is connected in parallel with the opposite pole switch. This RC combination constitutes the unpolarized snubber network. Normally, inductor cannot allow sudden change in current. The snubber circuit protects the equipment that not allows sudden change in voltage. There is a protective element snubber circuit. The current limiter is connected in series with a feeder such that it can restrict the current in case of fault downstream. In the healthy state, the opposite pole switch remains closed. These switches are opened when a fault is detected such that the fault current now flow through the current limiting inductor. So this means in solid state current limiter, whenever the fault occurs, the current in the inductor is increases. Whenever the current in the inductor is increases, the opposite two switches are open. Opposite open means the current not flows from sending end to load end. This way, this will in solid state current limiter protects the load. Whenever the highest current is high current due to the fault, high current is flows, automatically the inductor current increases. Whenever the inductor current increases, automatically the switch is opens. Next topic is solid state breaker. We teach in next class.